Thank you. I'm Mr. Lehner, and welcome back to Mr. Lehner's Math Extravaganza. And in today's webisode, we're going to take a look at and build upon our families of triangles from yesterday. And if you're wondering, did I lose my razor at home? No, we're just doing a little beard contest for the month of February. So this will be around for a little bit over the course of the next month. All right, let's not waste any more time. Let's take a look at what we're going to review today. Okay, and our first question up here, it says the triangles both have a base of 4 centimeters and a height of 6 centimeters. Do the triangles have the same area? So I'm going to create two triangles. Here's my constraints. But what's a constraint? A constraint is what I have to make the triangle look like. Any type of constraint gives you specific parameters to build. So I have to make a base of 4 and a height of 6 centimeters. I'm going to try and come up with two triangles that have those constraints and then see. Did they have the same area? And again, I'm going to use my handy dandy ruler, my markers, and my grid paper over here to try and display that. Hopefully you have yours ready at home as well. Okay, let's take a look at our grid paper. We said we needed a base of 4 and a height of 6. Okay, so again, I'm going to go 1, 2, 3, 4. There's my base of 4. And let me mark that up so you can see it a little bit better. Okay, there's a base of 4. Okay, it also says I need a height of 6. So if I go 1, 2, 3, 4, 5, 6, anywhere up here, I can make my point. Well, I'm going to make my point here. This is going to create two perpendicular lines, which means I'm going to have a right angle there. So I'm going to mark my right angle, and I'm going to connect my triangle. Right down the top up here. Okay, I'm going to use my marker to make this come out a little bit. We got a right angle there on the inside. So again, here is my base of 4, and the height of my triangle here was 6. So if I did 4 times 6, that's 24, divide that by 2, the inside area of this is going to be 12 centimeters squared. Again, I'm following my constraints. This has a base of 4. This has a height of 6. 6 times 4 was 24. Divide that by 2. The area or the inside of this triangle is 12 centimeters squared. Now, if you notice, we talked about dropping our lines down to figure out where the height would be. 6 is going to be my height on this triangle. It's going to be the outside or the edge line here. I don't need to drop down any lines because I already have my perpendicular lines here creating a 90-degree angle. Let's try another example, see if we can find another triangle that fits these parameters or these constraints. Okay, so I'm going to start with my base of 4 again. Let's do 1, 2, 3, 4, and it's a height of 6. So 1, 2, 3, 4, 5, 6. So anywhere up here, and I'm going to go right here in the middle. I'm then going to connect my lines. Ooh, try to make them as straight as I can. Okay, and then I'm going to draw down my line down the middle, creating my 90-degree angle here. Make it a little bit more visual for you guys. And if you notice, I've made a special type of triangle. Hopefully you guessed that at home. This is an isosceles triangle where these two sides are going to have the same length. Again, my base here at the bottom is going to be 4. My height, which is now on the inside of the triangle, is going to be 6. So if I multiply 4 times 6, I get 24. Divide that by 2, I'm going to get 12 centimeters squared. So again, we can see when we're dropping down that height, this time the height was on the inside of the triangle. Again, it depends on the parameters of what your triangle looks like. But again, my base was still 4, the height was still 6. I followed my formula, base times height divided by 2, and I ended up with 12 centimeters squared. So I have two different triangles here, and they both have the same area. So it's a review of our families of triangles. If we have the same base and the same height, we're also going to have the same area, even if our triangles look different. Remember, areas like the covering or the inside. And again, perimeter is the surrounding or the outside, hence the name covering and surrounding in our book. All right, let's take a look at your example. And what I'd like you to do at home is to do our second one here. It says, the triangles both have an area of 12 square centimeters. Do the triangles have the same perimeter? So at home, you're going to take your grid paper, hopefully you got a marker or a ruler over there, and a pen or a pencil, and you're going to try and draw two triangles different than the ones I have, and you're going to try and get them to have 12 square centimeters as their area, and then figure out, do they have the same perimeter? Go ahead and pause this video, and we'll see what you come up with. Okay, so I know that I need to have triangles that have an area of 12. Now my first strategy that I would use is to figure out, well, I know that I have to divide the total area by 2, so I'm going to look for areas of 24 that I'm going to divide by 2. So I'm going to look for a base and a height that are a factor pair of 24. So let's just say, I'm going to make a base of 8 and a height of 3. All right, let's make sure we're here. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. Connect my line here. So I just made a base of 8 at the bottom, and I noted that I said I needed a height of 3. So if I go 1, 2, 3, I can connect this line again. This just made a perpendicular line here, which is going to be a 90-degree angle. And I got to connect my triangle. Ooh. Again, as best as I can up here. So, let me color this guy in to make it come a little bit easier to see. If I drew my triangle out like this, the height here of the triangle is 3. The base down here is 8. 8 times 3 would be 24. 24 divided by 2 would be 12 centimeters squared. Okay, and again, if you notice, that's similar to what I've done up here. They all have 12 centimeters squared. It's a third different triangle, but it has the same area. Okay, now if I was looking for another example, another factor pair of 24 is 6 and 4. So let's make my base 6. 1, 2, 3, 4, 5, 6. And my height's going to be 4. 1, 2, 3, 4. And let's just put our dot right here. I'm going to connect my lines for my triangle. And again, I can, if I can get it to go, I can draw my line down here, creating my 90-degree angle. I had a base of 6, and I had a height of 4. Again, I'll color in this triangle. A 90-degree angle. Not the neatest, but we can kind of see here. Our base is 6, our height is 4. 6 times 4 is 24, divided by 2, 12 centimeters squared. And again, don't forget to put that unit on there. You want to make sure that everyone can see what you're talking about in terms of how big or the size of your triangles. So this would be 12 centimeters squared. They have the same area. Now we were looking at perimeter. If I were to take out my ruler and I were to measure each one of these sides in centimeters, I am going to get a different perimeter for each triangle. So when looking at these types of problems, yes, they had the same area because they had, in this top one, they had the same base and the same height. Even though on the bottom that these two have the same area, it doesn't mean that they're going to have the same perimeters. Again, you can tell by the size of this 8 by 3, if I were to measure out the exact distance around the outside of my, or the surrounding of my triangle, I'm going to get two different perimeters. Again, it's kind of a way to build on what we talked about yesterday with our triangle fact families. Okay? Thank you for tuning in to Mr. Lehner's Math Extravaganza. As always, we'll see you next time.